AI replace bioinformatics or bioinformaticians rather in this era where technology has basically superseding the human expertise? So this has been, or this is the most critical question being asked nowadays, and it is the same topic that is rethinking bioinformatic expertise in the era of AI. This is the main title of the paper which has been published in NPJ Digital Medicine recently in May 2026, and it has been authored by Go et al. The authors are from various prestigious academic organizations across the globe. So rather than a technical paper, this is more of a perspective, a personal perspective of the authors, and it is really close to my heart as a bioinformatician because I am also experiencing the same insecurity nowadays since we as bioinformaticians or academicians are really becoming more dependent upon the machines. So the question, the fundamental perspective we must look into is that AI can do all sort of problem solving, can do all sort of problem solving duties for us. It can basically design a code. It can do some sort of technical skills. It can write the text for us. It can draft a manuscript for us. But the real question is, can it really understand the science behind all those tasks which we are for which we are dependent upon the AI? And can it really solve the problems from biological context? Can it really understand the biological context? And more importantly, can it really bring a credible solutions or validating solutions from humanity perspective? That's the core question for all of us in today's era of AI. So welcome back to BioEnigma Uncovered. In today's live session, we are going to cover about rethinking bioinformatic expertise in the era of AI, a perspective published in NPJ Digital Medicine. Moving forward, there are three transitions which are being discussed in this manuscript, or rather today in tonight's roadmap. So AI is basically meant to be a problem solver, but AI is certainly not a replacement for the human expertise. And because human expertise and human intervention is what will turn the acceleration provided by AI into real science. There are three major aspects or three major contours we must need to take into consideration. The first is technical, second is scientific, and third is organizational aspect. The first question or the technical aspect is that humans, which have been from the past few years, they are meant to be, they are being understood as AI consumers. Can they transform themselves to AI custodian by means of better prompting, by acquiring better prompting skills, by understanding the data and the explainability of the solutions or the answers provided by the AI? The second perspective is more scientific, that can the solutions which have been provided by AI will help us from transforming ourselves to pipeline executor to discovery pioneer? That is one of the hardest problem or the biggest challenge for us. And the third is more related to ethicals and the leadership roles in for bioinformatics in this era of AI. Now let's understand all these things one by one. Hmm. So from technical perspective, the everyone is asking the same question. If AI can draft the pipeline, AI can execute the pipeline, if AI can annotate the sequence for us, if AI can identify the amplicon sequence variants or the metagenomic variants, and it can also interpret those things, what is left for us as a bioinformatician? Well, the answer is everything what is left, because AI can do all those things. But from biology point of view, can AI understand, or can AI validate all those solutions which has been provided through the execution of a specific pipeline. So, hmm, understanding the AI, understanding why requires being honest about what AI is actually doing and what it cannot do without an expert guidance. What it means that uh, AI can do all those things, but it is the human expertise that should sit right at the top, and it should see what is actually required. Because let's say for example, if AI is interpreting all our bioinformatic results and it is choosing a specific database for referencing all the annotated sequences. But the real question at the end will come into picture is that whether a certain database chosen by the AI model or the AI tool is rather the correct one or not. In that case, the human expertise become inconsequential and indispensable. Fine. So, uh, as a bioinformatician, I personally feel, or rather, the authors they say that bioinformaticians being the custodian for the AI, and they should have a better prompting skills so that as a consumer of the AI solutions, we should understand better what is AI providing to us. So in general, as a bioinformatician, or rather any person who is skilled in certain kind of technical skill sets, we are using we are seeing three kind of AI tools. First is generative AI tools or large language models. These include your Chat GPT, Google Gemini, or Claude AI, and so on. The So these are more generic tools. They can produce the text, they can write the code, and they can also provide some structural output in terms of statistical analysis. So they are more, you can say, the driving force behind that critical questions that is being asked today. That is the replacement narrative. Fine. So the second type of tools are task specific and deep learning. They are more related to certain kind of bioinformatic related uh, things we do. Like for example, prediction of certain kind of protein, structural prediction for a certain kind of protein. For this purpose, we use certain kind of tools such as AlphaFold or AlphaFold 2, AlphaFold 3, or we are using some molecular docking, and we are using such tools such as Autodoc Mina. So for that, these AI tools, they are trained on certain curated domain data sets to provide a precise solution and related to some specified problem. The third kind of AI tools, they are agentic AI tools or hybrid systems. They are more of a virtual, for example, the virtual lab. So they will orchestrate the multiple AI tools and provide a reasonable steps or logical steps towards certain complex scientific objectives. Fine. So combining all these tools, AI will help us in recognizing certain kinds of pattern. It is going to generate certain kind of outputs which we interpret in the result and discussion section of any experimental manuscript. Okay, so by using statistical tools, it can provide us data which is basically mapped to certain kind of reference data sets. So all these things are generally well established and they are very powerful. And all these answers which are provided by the AI, they must not be underestimated, because AI is basically doing all those things in a very speedy manner, which a normal human mind cannot do. But the question here comes into the picture, as the author suggests, that the quality of the output is only as good as the expertise or the human brain who's basically trying to understand the problem or who's designing the research issue or the research question, and who's also curating the data and who is providing instruction or prompting the AI tool to do that particular to provide a solution for that particular scientific problem. So all so the interpretation or of the results and all the data which is being created will all depend on the individual mindset or individual expertise. So if any person, say for example, I am using certain kind of AI tool and I am doing certain kind of prompting to the AI tool to provide me certain kind of codes or solutions or certain kind of commands in Python to provide me a solution. So ultimately the limitation will depend upon the human brain or the human mind who is basically using the AI tool. Okay, so without AI itself cannot do all those things. So what I mean that without expertise, AI does not democratize science. It will only democratize how the scientific output will look like. So ultimately, the analysis which goes as the output, it should look rigorous and output that should basically sound authoritative conclusions nobody can evaluate. So ultimately, if those interpretations, suppose I am generating certain kind of data sets by using certain kind of AI tools, so it goes to some expertise who will basically look, who suppose if my data set goes to someone who is more expert than me in understanding that particular bioinformatic tools, they may question or they may basically raise the question on what is on the quality of the data sets being generated. So ultimately, the core limitation of AI will depend upon the expertise of an individual who is basically using that particular AI tool. So, so suppose, like I said earlier, that if an AI tool is writing a script, can it know if the script is right? If AI is using certain kind of reference genome to map certain kind of say metagenomic sequences or 16S rRNA sequences, does it know that it is using the correct reference genome? Or the statistical model it has chosen to analyze the certain kind of data sets are specifically right for a particular experimental designs? No, it is certainly not. So because only a human mind can understand what is the biological significance or the biological context of such bioinformatic applications. So ultimately, the code is there, the ability to understand the code is there, and the ability to basically prompt the AI tool to write a certain code for us in order to expedite the solution for finding a certain kind of biological problem will ultimately depend upon the human intervention. So personally, I feel is that AI certainly cannot replace the human mind. Ultimately, the science that is the science, it does not come inherently within the AI tool. Science will always come with expanding our knowledge, expanding our mindset. Only then we will know that any individual will come to know whether the results which are being provided by the AI they are trustworthy or they are scientifically validated. Fine. So, so overall, what we can say that with time, that is from the past 3 to 4 years, and even going forward, humans will become more, will transition more from an AI consumer to AI custodian, because personally we will be, as specifically a bioinformatician, we will be personally responsible for whether the outputs which have been generated by using certain AI tools they are correct, reproducible, and biologically uh, meaningful, or they have certain kind of biological significance. So ultimately, as I was explaining earlier, or the use of AI tool will depend upon the individual expertise. And for that, we need to become a better prompt engineering. That is why prompt engineering is rapidly evolving as a valid scientific skill, irrespective of the domain, uh, whether it is, say, suppose data science, bioinformatics, or conventional computer sciences. So, a major fraction of our skill sets will depend on the 20 to 40 percentage points of our performance swing on the uh, identical biological task, that depending only on how the prompt is written. So clearly there are broadly there are four aspects or four attributes for uh, for uh, a prompt engineering skills. First is it is a reusable asset. Second, it is fragile. Third, it is going to expire. And fourth, it scales into AI agents. Let's talk about the first point, that is the prompt engineering is a reusable asset. Okay. Hmm. Hmm. Because by using a appropriate prompt, we are going to instruct the AI to provide specific codes related to a specific problem. And this will help us in getting certain kind of outputs and which we can test and later on publish. However, hmm, this prompt engineering, it is fragile because the reasoning behind every prompt, it will vary from individual to individual. Suppose I am looking a certain kind of, say suppose I want to design a certain kind of drug molecule for a non-communicable or a communicable disease. So my mindset will my will depend upon my expertise, or it can also depend upon like uh, demography to it can also vary from demography to demography. Suppose I want to design a drug molecule for the treatment of diabetic nephropathy, but we all know that diabetes or its complications are more often environmental. They vary from the severity of the disease varies from environment to environment or from demography to demography. So from what logic I am basically seeing as an Indian, those logics may not apply or they may not fit into the logic for a European descendant or for a person from uh, US descendants. So ultimately, the reasoning or the chain of thought reasoning can basically still land on the wrong conclusion. Another thing is, since AI tools are evolving on a day-to-day basis, so that is why a prompt which may work today and it may not work tomorrow. Because why? Because the database of AI tools or LLMs, it is expanding day by day. So one tool or one prompt which can work today, it may not work on the same tool on some other day or in the near future, or even the answers to that prompt, they may vary from prompt to from tool to tools. Like say suppose if I provide a certain prompt to the chat gpt and the same prompt to Google Gemini or to the Claude, I may get three different type of responses. So that is why AI tools are, we can say, they can behave differently. So ultimately, the AI tools can also be scaled into agents. For example, the virtual lab shows that domain expert who architecture the whole teams of specialized AI agents, they are not just single prompts, means they are basically large set of prompts. So so the ultimate moving on. So what AI learns will ultimately depends upon what is present within its database. So that is why you also come you also see onto your computer screen whenever you use ChatGPT or Claude AI or some other tool, it always come with a prompt that AI can make mistakes or ChatGPT can mistakes. Why? Because what AI learns from is what AI knows. So it can have some biased information, it can have information which is biologically irrelevant into its data sets. So in that particular scenario, it can produce biased, mislabeled, or uninformative outputs. So that can all these things can be delivered with total confidence. So uh, for example, additionally, a batch effect can hide in a training a data set before it becomes a signal. Besides, uh, Uh, for example, like I mentioned earlier, that what prompt you provide to AI today and the response you get today will only depend upon what information is stored in its database today. In a few days coming from today, and say after 1 month, you provide the same prompt, and you will definitely going to get different set of responses. Okay. So the real finding in, say, suppose drug discovery is that fixing the data quality and not the model architecture. So ultimately, it will depend upon, so the solution which is being provided by the AI will depend upon what is stored in its databases. The larger the database it has, the more you can say viable solution it can provide. So moving forward, so the last line of defense is this, that explainable AI, which stands for XAI, it does not explain, it only provides something informative which you can interrogate. So, for example, it can provide an hypothesis which should be verified experimentally. Okay, it can also provide a candidate for the expert to evaluate. It will not provide a justifiable or validated explanation. And uh, in terms of like statistical, it can provide you confidence interval which are far more useful than a confident point estimation. Moving forward, that is the second transition, that is driving discovery, where it is hardest. So there are two places where generate AI is basically subjected to certain kind of limitations. First is the multimodal integration, and second is high complexity applications. Okay, because AI can basically provide you certain kind of codes, but it cannot understand what is basically required by a clinician. Okay, so for example, AI in the language of machine learning, it will provide you certain kind of features, but those features are basically may be referred to as a biomarker. I'm talking about strictly from biology point of view. So if you basically find it difficult to understand, you can just let me know in the comments. So in that condition, specifically, let's suppose we are doing analysis of certain kind of genomic data sets, and we have a clinical records, and we are doing the imaging. So we provide a prompt for an AI algorithm to provide the interpretation. Okay. And in the interpretation, the ML model or the machine learning model or the AI tool uses certain kind of language. But those language can differ from what is being used by medical practitioners. So unless they both come to understand, and the clinician basically comes uh, and uh, and the clinician will not able to understand what is being provided by the AI tool. In that condition, the bioinformatics will come into the picture, and it will come as a transitioner, a translator between the solution provided by the AI tool and what is to that, how that information or the solution which is passed on provided by the AI tool to the clinician. So in all these contexts, just from medical point of view, the role of bioinformatician as an expert will become central and not the peripheral. Hmm. So in many cases, AI models can provide you wrong answers, but in absence of an expertise, those wrong answers may not may not appear wrong. So, for example, AlphaFold 3, it is a remarkable tool, but the solution or its value which is being provided by this AlphaFold 3 will depend entirely on who is basically using that particular tool. Let's say understand this from a very simple example. Uh, Suppose a technical person is using an electron microscope and you ask any layman to use that electron microscope or analyze the images provided by that electron microscope. Simply, they will not be able to provide the analysis or the solutions or derived from that electron microscope analysis. Simply and similarly, the any person who is basically able to understand the solutions provided by the AlphaFold 3 will become irrelevant or become dispensable. Say suppose AlphaFold 3 is providing us three major solutions or three major questions. Like, for example, the data set we generated from AlphaFold 3 analysis, it gives us three questions that which protein families get unreliable predictions, how should the confidence scores be read in disordered regions, or do the structures prioritize real mutagenesis experiments. So all those questions can only be given, the answer to all these three questions can only be provided by the expertise who's basically using that AlphaFold 3 tool. So ultimately what is that the only the person who is using the tool or the machine will be able to provide the right answer. So that comes to our final transition, that is more from an organizational point of view, that human brains or human expertise should move from contributor to the institutional architect, and this is where the ethical questions come into picture. Now, in this particular paper, authors have basically mentioned one paper that was published by Obermeyer et al. And this paper was published in 2019. And that paper basically discussed the use of certain kind of a training tool or an algorithm which used healthcare costs as a proxy, and in that particular it says that for black people the healthcare costs or the black patients for the black patients the healthcare costs were relatively higher compared to the white patients with equivalent disease burden. So this paper had an hidden bias because it was only considering the healthcare costs based upon the skin color. Okay, but it was not the algorithm which was used in this paper does not consider the does not consider the healthcare quality available to the black patients as compared to the white patient. So ultimately, the authors argue that these AI tools or the algorithms do not have the tendency to democratize the biological context or the humanity context. It is in that particular scenario the human expertise becomes indispensable because in the appearance or emergence of ethical risk will ultimately lead to the risk in science. So that is why new rules are coming up are being basically curated by the regulatory agencies across the globe, whether it can be European Union or the US FDA. For example, in the use of AI into medical devices was initiated by EU in August 24, and they are considering considerably expanding it as I am basically doing this video that uh, they high risk systems or conformity assessment or human oversight over the use of AI or the solutions being are provided by the AI. They are being so the rules related to the AI usage are being incorporated into the government acts or the rules and regulations, and by 2027 these rules will be fully compliant for the regulated use of AI in medical devices as under the expertise of European Union AI Act. In parallel world, US FDA is also coming with certain guidance on AI-enabled medical devices in USA. So the bottom line is that the bioinformaticians who basically lead clinical AI translationals now operate where the scientific cares for expert oversight and the legal obligation to provide it point the similar direction. So mm, uh, and the question, so the clarifying question that is, do you understand the science deeply enough to know when the machine is right and when the machine is wrong? And in that particular scenario, bioinformaticians, the role of bioinformaticians into the use of AI is going to become more integrated, more prominent, and simply human expertise. It is simply remains uh, undisputed. So as the custodians of AI, our duty is to provide indispensable conditions for AI to be useful rather than being dangerous. So finally, let's discuss in more critical point of view. If you have certain questions related to the use of AI in bioinformatics, whether you are a student or a teacher, just drop in your chat box. I'll see you in next Journal Club video at 7:30 p.m. next Sunday. Till then, take care. Bye bye. Thank you so much for watching this video.